Good morning guys and welcome to my channel Mind Your Math. Today our sum is based on circles. So it is just the basics of circles which you study at the school level. The area of a circle, the area of the sector of a circle, diameter, etc. etc. Now the diagram has been given to you. I have not drawn the diagram on the board which I will be doing shortly. Before doing that, now let me tell you the prerequisite knowledge that you guys need in order to solve this particular sum. Before moving on to the diagram that the question has given us, I just tried to draw a rough diagram of my own in order to figure out how exactly they drew the diagram. It is given that PQ is of length 4 units and it is the diameter of a circle, which means O is the midpoint. So this is 2 units and this is 2 units. Three semicircles are drawn on PQ in such a way that the centers of the semicircles are spaced equally, which means that this is the center of the first semicircle. Now the second semicircle has the center O and the third one, let us say this has a center B and this is A. If they are spaced equally, the radius of the first semicircle is a 1, the second one also is a 1, everything is a 1. Okay, now we need to find the area of the shaded region, which is this. Okay, now let us see how we can break down this sum into smaller parts. In the diagram that is given to you, this part, that part is not shown, it is erased. So this is the diagram that is given to you in the question. Now in order to find the area of the shaded region, which is this region, you know that the area of the bigger circle, we can find it out very easily by using the radius, whose radius is 2 units. From that area, I need to subtract the area of this and this. Fine. Now we have no idea about the angles that are contained by the sectors. If we knew the area, if we knew the angle, we could have easily found out the area. I can easily find out the area of this particular circle, but I don't know the angle that is contained over here, and there is no way to find the area of that particular sector. So now let us see how we can do this sum. The area of the bigger circle is the area of a circle of 2 units radius and it is a semicircle. You can see that there is only the upper part of the circle over here. Area is given by pi r squared. That is the area of the complete circle. To find the area of the semicircle, we have to divide it by 2. The radius is a 2. So pi into 2 square by 2, which is a 2 pi. Now I have gotten the area of the larger circle. I need to subtract the area of these three parts from 2 pi. I have drawn the lines AX, OX, OY and BY in the diagram. Now, the length of OY is the distance between the center of the middle circle to the circumference of the semicircle. So, you can say that it is equal to the radius. Now, the radius is 1 unit, so I can say that this is also 1 and this is also 1. What can you say about the distance BY? It is the radius of the last semicircle over here, which is BY. So this is also 1. Similarly, this length is also 1. All the three sides of these two triangles are equal to 1 unit. So I can say that they are equilateral triangles. Hence, the angles will be equal to 60 degree at the vertices. So this is 60, this is 60. This is 60, this is 60, this and this are 60. So let us mark the angles that we can get from this particular diagram. All the angles are marked as 60 degree. Now at this particular point, this and this are 60 degree. So the center angle is also 60 degree because the sum of angles should be 180. So this angle is also 60 degree. Now, if this angle in the triangle is 60, what is the complete remaining angle? This is 120. Similarly, from this line here, it is a 120. At the center, Now you are having a sector having an angle of 60 degree. The area of this particular sector XYO is given by 60 by 360 into pi r square, which will give us a value of pi by 6 unit square. Now, when you look at the sector which is held by YBQ, I have drawn it over here. You can see that the angle subtended is 120 degree, which we have found out from the diagram. Now, let us find the area of this particular sector. You can see that the area contained by that particular sector of angle 120 degree is given by pi by 3 square units. YBQ has pi by 3 square units. That's the same area subtended by XAP because they are identical. So that area which is from here, this is also pi by 3 square units. Now, what is remaining are the areas of two equilateral triangles whose area can be easily found out by using the formula root 3 by 4 into a square. We know the value of a, this is a 1. So, I have the area as root 3 by 4 into 1 square, which is a root 3 by 4. That is the area of one triangle. The areas of two triangles will be into 2. Now, let us sum up all the small areas and see what it will come to. Area of the smaller parts have been added up. Area of two equilateral triangles, area of two sectors of angle 120 degree, and the area of the middle sector, which is pi by 6. So adding up, this is what we are getting. Now let us subtract it from the total area of the bigger semicircle. After the calculations, the required area has been found out to be 7 pi by 6 minus root 3 by 2. So we can see that our option E is the right one.